We're looking at charging by induction. Charging by induction is the third way you can charge something with static electricity. Remember, friction, conduction, induction. Induction comes from the word induce, which means kind of like to convince somebody to do something, okay? So I induce someone to litter. It means I kind of trick them or I convince them to throw litter on the ground. And of course, nobody would ever do that because you'd be in big trouble. Now, let's look at it. So when you see induction or when you see a question and you're not sure whether it's induction, a couple of hints is it basically means to kind of like to influence, okay? To induce means to influence someone. And often it involves things that are near, okay? They might not be touching. Why? Because this charging means no electrons are jumping from one to the other. So often they're not quite touching. Okay, so let's take a look. I'm going to start with this object. I'll throw in a couple of negatives, but obviously it is very, very positive. This one, if you count it out, it's 4 positives and 4 negatives. It has a charge of 0. It's neutral. Now, when I bring them close, okay? Oh, sorry. When I bring them close together, and I bring them close, what's going to happen? Well, they're not touching, so they can't charge by conduction and have electrons jump around. So when they're close, this positive material is going to influence, it's going to induce the charges in here to move around. They can't jump off because they're not touching. So let's take a look. This, I bring it close, and this is very positive. The positives never move. Only the negatives can move. Do negatives get attracted or repelled by positives? Well, you know the rule, opposites attract, so positive and negative, they're going to attract. What's going to end up happening is these guys are all going to move over, and I'm just going to erase it, and you're going to see how they end up. They're all going to end up all lined up as they're trying to come over here, but they can't because they're not touching. Okay, so let's erase each one of these. And we're going to put them in their final spot. Okay, I'm not doing the whole before, during, and after series. I think you can figure this one out. So it would be 1, 2, 3, 4. And they would line up on this side. Now, why does this matter? Well, it explains why something that is neutral can get attracted to something that is positive. When I charge a balloon with my hair, it makes sense that the balloon is attracted to my hair because the balloon, through friction, got charged negative. My hair became positive, and so positive and negative opposites attract. But when I take that balloon and I put it on the wall, it still sticks to the wall even though the wall isn't positive. Why would a charged object be attracted to a neutral object? Well, it turns out this is what happens. A charged object can make the neutral object make the negatives move around, and what this ends up looking like is you end up with something that on this side has what we call a differential negative charge, okay, and a differential positive charge. That's just a fancy way of saying that this thing is kind of like a magnet. This side is more negative than this side. It's not that the positives moved. The positives are still spread out, but this is more positive heavy, and this is more negative. And when this becomes more like a magnet, it actually gets attracted, even though overall it's still neutral. So charging by induction means that a charged object has induced the charges to move around inside, and it's made like a magnet. Now let's look at the opposite situation. The opposite situation is I have something that's very negative. I bring something neutral close to it. You might instinctively say, oh, the positives want to move, but you know that you're going to be in big trouble with me if you ever do that, so you're going to move the negatives away. Why? Similar charges repel and only negatives can move. The negatives move away. Okay, they all go to the other side, and when I redraw them, I'll get my fingers dirty. When I redraw them where they end up, the positives didn't move, but the negatives were all pushed away to the other side. So overall, this thing has a differential charge, positive differential charge on this side, and a negative differential charge on that side. You don't have to memorize that little letter. I don't need you to ever draw it again, okay? But you should know that this side is more positive and this side is more negative, and it kind of acts like a magnet. The positives are kind of spread out, but the negatives are all lined up at the far side, and so it gets attracted. When have you seen this? Well, if you rub a ruler and you bring it near little pieces of paper, confetti, we did that in the lab, you'll see that the confetti jumps up even though we didn't charge the confetti. The confetti got charged by induction into tiny little magnets. The example of the balloon that sticks to the wall. Anytime you have something that's charged and something that's neutral and they're attracted, the charged one is making the neutral one sort of like a magnet by induction. Okay? And it also explains that stream of water trick that I did with the ruler. That's a really cool one. Basically, the water molecules kind of are already like little magnets, and they kind of line up so that they're attracted to the ruler, and you get that fun little demo. Okay, so as a recap, charging by induction starts off with one object really charged, one object neutral. You bring them close but not touching, and the charged one rearranges the charges in the neutral one, and that one becomes like a magnet, and that's why they attract. Now, the neutral one never actually changes. It's still neutral, but inside it's rearranged. Okay? That's actually another thing we can say. It's kind of like rearranging charges inside. Rearranging. Oh boy. There we go. Rearranging. The example, well, your charged object can be positive, in which case the negatives are pulled towards it and you end up with a magnet looking like this. It's not a real magnet, but it kind of acts like one. Or you can start with the charged object being negative, in which case it's going to push the negatives away. And you always know that the positives never move. So that is charging by